so you can see something. So this is how it goes. Are we good?
Very good.
So, hello again. I'm very excited to welcome you to this webinar about pond aquaculture. My name is Luca Regazzoni. I'm a research associate, just a researcher at the Zurich University of Applied Science. And my field of expertise is mainly everything that has to do with wastewater and water quality in aquaculture. I've been working on a project in Cambodia together with Ben, who I'll talk about next. But next to that, I also do a lot of recirculating aquaculture system research and so on, data analysis, a lot of lab work with different analyzers. And I'm very happy to have Ben Scott here as well. He's an aquaculture project manager at Sustain and production manager at Tankanyika Blue in Tanzania at the moment. And I guess you can introduce yourself a little bit, Ben, if you want.
Yeah, thank you, Luca. It's wonderful to be here. Good morning, everybody, or hello, depending where in the world you are. As Luca said, my name is Ben, and I currently am working for two companies. One is Sustain, where I'm the project manager in aquaculture, and then I'm also the production manager for Tankanyika Blue in Tanzania. For Sustain, I'm mainly helping them with the expansion of the Tankanyika Blue, where Sustain is supporting Tankanyika Blue. For Tankanyika Blue, they are currently on Lake Tanganyika and have a small farm, but are expanding to a 500-ton Tanganyika tilapia farm with a hatchery in Kigoma, Tanzania. What's special about that is Lake Tanganyika has a moratorium on Nile tilapia production. So you're only allowed to farm national species in the lake. So Tankanyika Blue is starting a native species fish farm with Oreochromis tanganyikae. And that is very exciting as it is, although it is a type of tilapia, there's interesting things to learn about it.
Thank you, Ben. So the agenda for today is that I will first talk a little bit about pond aquaculture in general. So what kind of production forms do we have? So it's not just, or you will see that it's not just a pond with one possibility, but there are a lot of different possibilities how you can operate such a pond. Then I'll hand over to Ben and he'll talk about the whole operational cycle. So how you start a cycle of fish production, what steps you have to do to reach large fish in the end. And we'll talk about some general experiences from his work in Rwanda, Tanzania, and Cambodia. And then he'll hand over to me again, and I will go a bit more in depth into water quality management, into theory on how we can reach good water quality, how we can have enough water for fish production, and then we're finished. So the first question is kind of what is pond aquaculture? I would say it's the most simple version of aquaculture you can do in a way. It's very non-technical if you want it to be. So if you just have a pond, you can basically start without anything else. And the definition is that it's a type of aquaculture that involves raising aquatic animals. So we don't just talk about fish, it can also include shrimp or something else. And it's a controlled environment. So it's not an uncontrolled environment like you would expect in the ocean, because you cannot really control the water there. I mean, you can up to a certain degree, but not really actively. It's the oldest and most widely practiced form of aquaculture. You see on the bottom left of the slide an excerpt from a Chinese literature that is 2,500 years old, and it explains how to raise fish. It's a bit less scientific, I would say, compared to today, but it's the first written proof of aquaculture. Aquaculture goes back even further. We have a few key characteristics. We regulate the water quality, or we try to. We feed the fish in some operational management forms, and we regulate stocking densities. That means we take a look at how many fish we have in relation to how much water we have. And this controlled environment gives us the ability to monitor the health of the fish. You can see if we have sick fish, we can maybe treat them. We can, we can really regulate that, and can also regulate the growth. So we know how much we feed, and that influences a lot how fast the fish grow. There's a relative simplicity to the system, especially technologically. If you compare it to, you might know, recirculating aquaculture systems, they are at the other end of the spectrum. They are highly technical. They're closed or almost closed systems, and there you need a lot of electricity and a lot of technical compartments to even operate such a system. And as I've said before, you basically only need a pond to start pond aquaculture if you do it extensively. And so also the cost, the operational cost at least, is very low. It can obviously take some money to dig a pond, to excavate it, but generally it's low cost. So we can compare different production forms in pond aquaculture. So there's not just one possibility how you can raise fish in a pond. You start, the most simple is just stocking. So you just add some fish to the pond. You wait until they are big, and you harvest them in some form or the other. You can harvest a few, you can harvest all of them. But this gives you comparably a low production amount. So if you want to raise more fish in your pond, you would have to add something to the pond to increase productivity. So the first thing is fertilization. You can see the pond turns green, meaning we have an increased algae population and an increased plankton population. That means the fish have more food and they have more oxygen. So you can increase the stocking density again, and compared to just stocking. So you will get more production out. You can increase it even more by adding fish feed, external fish feed in pellet form, for instance. Or also, it can also be self-made feed from rice bran, for instance, in Cambodia. This is often done. And you can go further, because if you add fish feed, it's usually, you can do this up to a certain degree if you still have enough oxygen, but this will get very quickly limiting for the fish, because oxygen is very badly soluble or very poorly soluble in the water itself. So you can aerate the water using a paddle wheel, or there's a whole range of possible technologies you can apply to get this aqueous oxygen into the water, so it just dissolves the oxygen so it can be taken up by the fish. If you look into the literature, then there's often water exchange as a next possibility to even further produce increased production capacity. But in my opinion, this is kind of this is on the border of then changing the production form. Or there needs to be a differentiation, because if you exchange water, then it's still a pond, but it gets to be a flow-through system. So the management itself is different compared to pond aquaculture. If you look at some numbers, you can see those are basically the same production forms as we looked here, as we've seen here. And We have on the x-axis the production capacity in kilograms per hectare. It's not described as kilograms per water volume, but per area of pond surface. This is because ponds are usually, they're not very deep, and the depth of the pond is usually dependent on the climate. So if you have very humid weather, you would need less pond depth compared to very arid climate where you have less water, where you need a bigger safety, you can say, because more water is lost through evaporation and so on. So on the y-axis, we have the management forms. You can see stocking only. It's quite it's a very low production capacity. We have up to 500 kilograms per hectare for tilapia and less for catfish. And this increases by approximately sixfold if you stock and fertilize. If you add supplemental feed, you can get 1,000 kilograms per hectare more out of the pond. So we are at 4 tons per hectare and so on. Yeah, and you can see that continuous aeration and emergency aeration is also important. Emergency aeration is if you would only aerate if the dissolved oxygen concentration is at a certain lower limit, let's say 4 milligrams per liter or 5, when fish start gulping. But this will mean as well that if you don't aerate, you will have less oxygen in the pond, especially during the night. So you can continuously aerate using a paddle wheel or any other technology, and you can get significantly more, you can produce significantly more fish in the same area. And then comes the water exchange. This is really dependent on how much water you exchange, but then you can increase productivity even more. But this is just some figures or some numbers to give you an idea what you can expect. All right. Then I hand my word over to Ben.
Thank you, Luca. So the next few slides, I'll just go through some of my experiences working with pond farming in Cambodia, in Rwanda, and now in Tanzania, but also kind of a step-by-step guide of what you, as the potential farmer, kind of need to focus on when you're going through these steps of starting and then operating a pond aquaculture farm. So initially, you'll start by designing your pond. And this is different for anybody because the factors are very different. It really depends on what kind of fish you'll be farming and what kind of fish production you'll be doing. Are you operating a hatchery or are you doing grow out, where that completely changes what kind of pond you want. Then it'll go to the amount of production. If you want a highly intensive fish pond or something that's very extensive just in your backyard so you can get fish once a week or something like that. Then another very important thing is the weather and climate. As Luca mentioned earlier, if you're in a very dry, hot place, your ponds will probably need to be deeper, so evaporation is less of an issue. But also if you're in a very cold place, they should also be deeper so the fish can swim to the bottom where the water doesn't freeze. But if you're in a tropical place, they can be less deep as well. As you can see on the picture on the right, this is currently in Rwanda where the altitude is fairly high. So the air temperatures can get quite low at night, below 20 degrees Celsius. And that's quite of an issue for Nile tilapia, especially for the very small fish. So you can see the greenhouses in the background. Those were for the fry and fingerlings, just so the temperature wouldn't get too low for them at night. The final thing is the water availability. If you're in a place with not much water or where water is an expensive resource, it really will change how you design your pond And also what you'll have, will you use pond liner? Will it just be clay and things like that? As you can also see on the picture on the left, you can see very different styles of ponds. So this is from Cambodia, it's Gecko, where I worked for 5 years. On the top of the picture, you see a large pond. This is a big irrigation pond. So the water is very deep. These ponds were used for intense production. As you can also see in the background, they are paddle wheels. This is for aeration of the pond. And then towards the bottom of the picture, you can see the construction of small ponds being built. These would then be used very differently. This will be much more extensive, so aeration is much less of an issue. It'll go over to the next slide, but we don't need to go right now, Luca. But in construction, oh, that's actually fine. You can go already. That's good. When you start construction, you will also need to think about the weather and climate. In the picture before, you could see the small ponds had water in. We had started construction way too late, so the rainy season had already started. And as you could see, as we were digging the ponds, water kept coming up from the ground. But anyways, once you've started, you've designed everything, you know what kind of fish you're growing, you know what your pond wants to look like, it kind of goes to the construction phase. And this can also be incredibly variable depending on what needs you have. And the construction form will also change a lot depending on how much money you have, but also the makeup of the soil. So if you can see on the picture on the left, the soil is very, very loose and not many rocks. So it was quite easy to do it by hand. And we did it by hand then. So this is in Kigoma in Tanzania. Also, the availability of cheap labor was quite abundant. And the ponds that we were digging were very small. So digging by hand is quite an option. If you want a large pond that's 1 hectare big, you might want to consider hiring a bulldozer or an excavator. That also depends on how deep your pond will be. If you're digging a 3 or 4 meter deep pond, you might need an excavator where that can get quite difficult by hand. There's a very good link to pond construction from the FAO that also goes into pond design. And I highly recommend using that. That'll probably be in the description below, I assume, in the YouTube video. And it's something I'd really recommend to anyone that's starting in some pond construction or is just generally interested in pond design and pond construction. When you're designing and doing the construction of the pond, the most important thing will be the walls of the pond, because you do not want to dig them too deep, too steep, or too shallow, or not steep enough. The main thing will be on how much space you have and how deep your pond will be. On the picture on the left, here the walls will be going straight down, but that's because the ponds, these will be hatchery ponds, are for a hatchery, and we're going to be using concrete walls. So these will basically be fish tanks that are sunk into the ground. On the right, you can see the bulldozer pushing, but you can also see pond liner. This is then also because the soil is very sandy, so it would not keep any water. So that also factors into how are you doing your pond and how are you designing it? Will the land keep water? If you have a pond liner, the walls can also be much more steep. If you're not using a pond liner, you need to be much more careful on how steep the walls of your pond will be. If they're too steep, the walls will just collapse and you'll lose a lot of water. So while pond farming is usually one of the cheapest forms of fish farming and the easiest, especially compared to RAS or even cage farming, the most important things will be how do you build your pond? Because if something goes wrong there, you've lost all your fish and you've wasted a lot of money. We can go to the next slide, Luca. So once you've constructed these ponds, the next thing will be water. And it's arguably the most important thing in fish farming, as fish without water just don't live. So water is also a very big resource in fish farming, and you generally need quite a lot of water. So if you are in an arid place where there's no secure amount of water, fish farming probably is not a good idea. Even aquaponics or RAS, they do still need a lot of water, even though it's less than other forms of aquaculture. So when you've finished your pond, you filled it up, water exchange might be necessary. This is also depending on how you do your fish farming. So on the right picture, this is pumping sludge out of one of these ponds after a year or about 9 months of fish farming. So we didn't do any water exchange for around 9 months. And what we did here was we took a sludge pump for sewage, and we just put it at the bottom of the pond to just suck up all the sludge that were gathered there over the first cycle. And as you can see, it's very dark, very goopy, and very good for that ginger that was growing there. And here we didn't even remove that much water, as in Kampong Chnang, the area we're doing this pond farming, water scarcity was quite an issue. As the monsoon season was long and extensive, but there was also a period of just dryness where there's no rain. So having deep ponds that could keep the fish through that whole dry season is quite important. And a lot of these farms did not have the possibility to refill their ponds by pumping or getting municipal water. So they mainly used the rains. Then this water exchange was mainly just to get the toxic sludge at the bottom of the pond out. So we removed maybe around 5 to 10% of the water volume for this exchange. On the picture on the left, we see the tanks that were getting constructed in the earlier slide. And these ponds are a little bit more intensive. So this is a small hatchery that we're using to produce broodstock. And here we exchange the water every 2 to 3 weeks. And when we exchange it around 50% of the water. The initial planning was once every week, but it's important to always monitor your water quality. And as we saw over 3 weeks, the water quality was still okay. The nutrients in the water, especially the ammonia and ammonium, were quite under control. So we decided to wait an extra few weeks. And that's usually quite good, as where this hatchery currently is, there's not that much water, and it is fairly expensive to get it from the municipality. So if we can extend it to the water exchange every 3 weeks, we are saving around, 100,000 shillings? So around $25 to $30 per week, which we are saving, which is quite a lot of money. If you are doing large scale shrimp farming, tilapia farming, as seen as in China and Vietnam, their water exchange is also much more necessary, as they're really pushing the limits that those ponds can deliver. It is a little bit of a disputed discussion on water exchange, where some people think the water exchange is not really necessary, but there it's most important to understand what's going on in your pond and understanding the fish, where some fish can handle some higher ammonium, some higher ammonia, some higher nitrite, other fish cannot. And these ponds that we have here at the the hatchery, they also have continuous aeration. So we can also push it a little bit more. Okay, next slide, please. Here we're going to water quality. Once you filled your pond, you have the water, the fish are in it. Water quality is going to be the next important thing, because this is what's going to kind of change your farm to being successful, or you just losing a lot of money. The most important thing to be monitoring will be dissolved oxygen, as a lot of these ponds are usually green water ponds. So algae will be producing the oxygen for you. But as algae and phytoplankton, you need sunlight to do that. Generally, early mornings, the oxygen level can be very, very low in your ponds. This needs to be monitored very carefully, as it can really ruin your day and your fish's day if there's not enough oxygen. So we can see on the picture on the left, this is Thierry in Cambodia. We measured oxygen every day twice. Early in the morning, just as the sun came up, and then late in the afternoon, just so we could see how the pond was doing. Also, late in the afternoon, for example, if there'd been very cloudy and there'd not been much, not much active photosynthesis, it meant we had a chance to react, either to exchange water quickly or to add some emergency aeration into the pond. On the picture on the right, pH is also very important, as it kind of dictates how toxic the ammonium will be for your fish. Luca will go into that more in depth later. What's most important there in operations, though, is that you always measure these things, dissolved oxygen, pH, EC, at the same time, because these green ponds, the water chemistry will fluctuate greatly depending on the time of the day. So the pond at lunchtime is a very different pond to the pond you have in the morning, because the oxygen will be very good, but your pH is going to be very high, because the amount of carbon dioxide that was in the pond in the morning from all this phytoplankton has been removed. Removing all that carbon dioxide increases the pH quite drastically. And the Nile tilapia can handle it, the pH, but if your ammonium is quite high, it will get quite stressful for your fish. Now, most pond farmers do not have the access to these very expensive probes, which is quite obvious. So the most important thing is that you go to your ponds every day, you get a feeling for your ponds, and you get a feeling for your fish, because the pond color, the pond smell, how your fish are reacting is just as important as a little number on a screen. If you get to your pond early in the morning and the fish are gulping, so they're at the surface trying to get oxygen out of the air, it means you don't have enough oxygen in your pond. So you need to observe how your fish are handling it. If you can see the picture on the right, these are our small pond units in Cambodia, and you can see the pond colors are very different. The reason these are so different is because we had different aerators in there. And the best quality pond there is the one in the middle on the left. Nice, light green. That's kind of the healthiest looking pond. The picture bottom left, in that pond, all the algae had died off a day or two ago. So it's still very dark. So this is just kind of what you have to go through, and I get a feeling, as every pond is different, on how your pond health currently is. We can go to the next slide. feeding is going to be a very important thing for your fish, especially if you want to end up making money off your fish pond and selling the fish. So what's very nice about ponds in comparison to RAS, aquaponics, and cage aquaculture is there is already feed in the pond for the fish, in the form of phytoplankton and zooplankton. So if you can't feed your fish pellets, they'll still grow in the pond, and that's quite nice. Whereas in cage farming or RAS, where the water is generally quite clean, there's not that much food for the fish to grow. So you need to spend a lot of money on getting commercial pelleted feed for your fish. It can also be made on site. So this happened quite a bit in Cambodia, where farmers would use soy meal or soya cake that they could find in the market. Soya cake is just the leftover soya after pressing it for oil, which still has quite a lot of protein in it. But then also rice bran, which is also a byproduct after milling the rice, but also leftover food, old rice, but also old vegetables, moringa leaves, banana leaves. The fish can eat all of this. And what's also very nice about pond farming, if your feed is sinking, the fish still have a chance to eat it because the feed's not going too far away. If you're in a cage farm and you throw sinking feed that sinks too fast, it'll just go to the bottom of the lake and the fish don't really get anything out of it. So you also have a chance to build trays and things like that that the fish can eat off. What is important though, when you make your own feed, is that you have, especially when the fish are very young, it is important that they get a high quality feed with a lot of protein, as that first stage until they're around 30 to 50 grams, they need really high quality feed so they can grow well, because that's where they're still developing a lot. The feed will really impact the quality of water, even more so than just having fish in there. So being able to make sure that the feed is completely consumed is very important. If you have floating pellets, it's quite easy. Once it's gone, it's gone. But if your feed is sinking, it can be quite difficult to assess if everything's being eaten or if it's just going to the bottom of the pond, as the fish eating is also a sign to see how healthy your fish are. So what some farmers did that we were working with in Cambodia is they built a giant sieve and they had it on the side of the pond. So they could just place the feed on that sieve, the fish could go and eat the feed. And that way the farmer could easily see once all the feed was gone. Next slide, please. And next to water quality, you need to monitor how your fish are growing, as it's quite difficult in these small ponds. As they're dark green, you won't see your fish at all. So being able to remove some from the pond for a short while, weigh them, have a look at them, see if there's any injuries, if there's any diseases. This will then also, once you weigh them, it'll show you if the fish are on track from your growing plan, if they're growing slower or faster. Will also tell you if you need to increase how much you're feeding or decrease. And just generally having a look at your fish once every 2 or 3 weeks will just be really good for you as a farmer. What we did in Cambodia, we used cast nets. These are just nets that you can throw and they sink and you can then remove a few fish out. What's really important here is you don't do it too often, as it is very stressful for the fish, but also when you're doing it, you want to work very fast and very methodical, because whenever you touch the fish, it's very stressful. So you want to make sure that this ordeal for the fish is done as quickly as possible. You weigh them, you put them back. It should be over in a few minutes. That's kind of the most important thing. If your ponds are very big, cast nets can also be useful, as seine nets might be a bit too cumbersome just for quick sampling. Please. This is maybe the most fun part. So this is harvest day. This can be done many different ways. It can also be done with a cast net again. This is then, especially if you don't want to harvest your whole pond at one time. And we had farmers that we were working with in Cambodia that they'll just sell like 5 or 6 kilograms at a time. So a cast net was perfect because you go remove the fish and then you can go sell off those fish until they're gone. If you have a customer base that's willing to buy out your whole pond, if it's like 100 or 200 kilograms of fish, that's also great. That's when you can use a drag net to empty out the whole pond. You will need more people for that, as it can be quite heavy. But generally, this can be done in a number of different ways. Another popular way is to empty the pond and then use a big drag net to get them out. But usually using a net is how it's done in these ponds. Next slide. So the next few photos will just be some impressions from some of the work that I was doing in Cambodia, but also in Rwanda and now in Tanzania. As there are various forms of pond farming. This first picture is just a hatchery that we worked at in Smiling Gecko, and this is a very simple form of hatchery that we used for Nile tilapia. The picture here is just of the larva after hatching. Next slide. So this will be, the next few pictures will be on grading, as grading can be quite challenging and it's a very important point for your fish farming, especially if you are getting to a more commercial level. Grading, usually you just use a small sieve or a grid that then separates the large fish from the small fish. Here it's currently being done on Lake Tanganyika. And as you can see, it becomes quite challenging as everything on the lake becomes more difficult than in the pond because you're on the water. Here, what we had to do is we had to bring a whole nother cage next to it and then grade the fish and then separate them. Next slide. What's also very important when you're working on a lake is that if the fish fall out of the cage, they're gone forever. What's nice in a pond is if you handling the fish and they fall out of your net or they fall out of your scoop net, they're still in your pond. They're not going anywhere. You'll just have to go get them again. But working on a lake like this is you have to be very sure that the fish have no chance for escape because once they get into the water, they're free, and and you won't see them ever again. Next slide. So these next few slides are grading in Cambodia. So although this is still a pond, it would be more similar to lake production and cage production as our pond was very big and very deep. Here we use similar tools where we just had a small grid and the small fish would fall through, the big fish would not, and that way we could separate them. Next slide. working here, you just had to be very careful and very precise with your movements. As you can see, we did not have anything prepared to catch the fish if they fell out. Next slide. So the next few pictures are grading in Rwanda at Freefish. So this is grading fingerlings before sailing. On the bottom right of the picture, you can see the grading sieve. And the bottom left of the picture, you can see some clean water. This is also water with salt, so the fish are not too stressed. What the farmers are doing is they're using a drag net or seine net to gather all the fish in one corner, and then they'll be scooped out and graded to be prepared for sale. Also, what's interesting here is, so these ponds are very shallow compared to other ponds. You can see they're around 40 centimeters deep. This is because Freya Fish did a lot of water exchange every day. So it's almost a flow-through system. Here they also used a greenhouse. As I mentioned earlier, it could get quite cold in Rwanda as the altitude was quite high at around like 1,300, 1,400 meters over sea level. Next slide. Yeah, here you can see a bit of a close-up of all the fish being put into the graders. Here they even graded into 3 sizes, not just 2 sizes, where underneath the first grader, there's a second grader. And the smallest fish that got to the very bottom of there were discarded as they were too small and were considered runts. What's important here, if you are operating your own farm and doing your own grading, is you need to be very prepared and have all your material ready when you start a task like this. As you are, usually because once you are working with a fish, you have to work very fast because it's very stressful for the fish. So you don't have time, 5 minutes to run and get another bucket. You need to have everything there ready so you can move the fish to the bucket, get them, put them into the pond again so they can reduce their stress levels. Next slide, please. So this is harvesting again. Here I just want to show you how different harvesting is from cage farming to pond farming. On the cage, everything is more challenging as you're out in the water, you're not allowed to forget anything, and everything's floating, so you don't have solid ground to stand on. Here, this is in Rwanda with Aquasante and Lake Kivu, just harvesting fish for the market. On the bottom center of the picture, you can see a big tank of water. There, one customer wanted live fish, so this is being aerated. Off the side of the picture, they had big ice buckets where they were killing with ice slurry. Also, what you can see here is the protective net in case any fish fall out, you can still keep them. And they're harvesting around 1.5 tons in this harvest. And these big cages, around like 19 meters in diameter, could hold around 60 tons of fish. So much larger scale than to other ponds. Next slide. There's another harvest going. Just mainly they use crates instead of nets for catching the fish, which is not ideal, but it's the fastest way to work. Next slide. So this is harvesting in one of the ponds, or maybe a mixture of cage and pond. So this is after slaughtering where we slaughtered in ice or just before slaughtering. So the fish will be put into these buckets after perching, and at the top right of the pic, you can see big cooler boxes with ice ready for us for ice slaughter. Next picture. This is us just loading a fish after purging. So in these green ponds, what is quite challenging, especially with Nile tilapia, is the off flavor. So because the fish are eating a lot of algae, they will get some off flavor on them. This is generally quite normal for Nile tilapia to taste a little bit muddy and earthy. What we did in Cambodia is we did a purging system. So we put the fish in clean water for 2 days before slaughtering, and this gave them a chance to clean their bowels, so there was less of an off flavor. And here we just put them onto a trolley and took them up to the ice buckets. Next slide. So this is after slaughtering and after killing with ice, they go onto ice and then delivered to the processing center. These here are just pink tilapia, which was a popular type of tilapia that is farmed in Southeast Asia. I think that's it from my end.
Yes, thank you so much, Ben. There was also a question that Salah sent to me. That there was last time the discussion or the question about pond contamination with algae that can be toxic, such as cyanobacteria. And I just want to quickly address this, how you can manage this problem. If you don't know, cyanobacteria, they can form spectacular blooms in the water, and so they just reproduce very quickly, and then you have a lot of biomass in the system. So the first mechanism is that they die and they use a lot of oxygen. So the fish also die because they don't have oxygen anymore. And the other mechanism can be that they produce harmful toxic substances that are also bad for the fish. And the reason why they are able to have these blooms is that they are able to assimilate nitrogen from the air. So in the top layers of the pond, they have a competitive advantage over different other phytoplankton. So they have this possibility because it's always a kind of a war going on in the pond. All these different phyto and zooplanktons are fighting for light. They are fighting for food, for nitrogen, for phosphorus, and so on. So they have this advantage in these top layers where the nitrogen to phosphorus ratio is very low. And how this is commonly done is that people add algicides, so chemicals that kill algae. In my opinion, it's a slippery slope because you also kill beneficial algae that you need. And the environmental impact of these algicides are just not good at all. So usually, or less bad things to do could be to break up the vertical stratification so that there is no nitrogen depletion in the top layer. That's one thing you can do. Or the other thing is to increase the nitrogen to phosphorus ratio so that the cyanobacteria don't have this competitive advantage through absorbing nitrogen from the air. But I mean, apart from that, there is not really much you can do actually. So you have to hope that everything is fine. All right. I hope this answered this question. Then we go on with a little bit more theory about water quality management. Some of you might already have heard this. I'm not sure, but I guess you did. There's a lot of things you have to consider a lot of parameters you have to consider when operating a pond. In terms of water quality, you just have the water itself, just the amount. This is not really water quality in a sense, but it's kind of the same. I want to include it in the same topic, basically. You have phosphorus, phosphates, you have nitrate, nitrite, ammonia, so total ammonial nitrogen, meaning NH4 and NH3 together, actually. You have the pH value of the water that Ben has already talked about. You have dissolved oxygen. This is just denoted as aqueous, so dissolved in the water. The same goes for CO2, carbon dioxide. Then you can have a gas supersaturation, which leads to gas bubble disease if you have too much gas. This is especially in the top layer of the pond a problem. You can have salinity, too high salinity, too low salinity. You can have alkalinity. So basically the amount of calcium in the pond or chemicals that act similar to calcium. You have total suspended solids. Turbidity is basically a proxy value of this. And you can also have heavy metals. So, I mean, the list is endless, basically. This is not the full list. There's way more that we could talk about, but I will focus on the most important. So water, we talk about pH and ammonia and dissolved oxygen as well. First, I want to talk about the water budget because, as Ben said before, it's basically the most important thing in a pond aquaculture operation, because if you don't have water, it's kind of difficult to have fish at the same time. Water always has an associated economic cost. You have to pump it, you have to get it into the pond, you have to maybe pump it out. So it's really worth something. It's not free. Even if you get it just through rainwater, it's still not really free. You have several different inputs and outputs in the pond. You can have an inflow. If you exchange water, for instance, you can have rainfall as an input, and you can have runoff as an input. Runoff is the amount of water that is not, if it rains, the ground is not able to soak up all the water, so a part of it just flows over the ground, basically. So this can be an input. You can also have seepage. If you have a pond with earthen or clay walls, then a part of, for instance, the groundwater can go into the pond. You have equally outputs. You can have evaporation, you can have an overflow, and all these different in and outputs, they check how much stored water you have in your pond. Exactly. So the goal of these next few slides is to basically be able to assess a little bit how we can make a water budget. So that means we have our months in the year and we try to assess how much of these different in and outputs, how is their influence on the chain of storage within the pond. So that means basically, do we have enough water to produce fish in a pond, basically. So rainfall is the major source of water in most humid areas. If you do pond aquaculture in arid areas, you are basically always dependent on a water source from a river or a stream. And to assess this rainfall amount, there's a good resource that the link is down here. You can basically check for any region on the earth how much rain there is per month for several different years. Here is an example from Cambodia from 1991 to 22. You have all this data you can look at. So here we get this precipitation amount in millimeters. It's in millimeters, so we can easily also calculate it into the pond depth, basically. You will see it later. So the next input we have is runoff. I've already explained that's the amount of rainfall that can no longer infiltrate in the soil. So it runs off, and you can catch that, and you can basically lead it into the pond. But it's important that the pond or the watershed of the pond is built in a way that this is also possible. Otherwise, you don't have any runoff. Then there's a simple but very rough assumption for this. It's very hard to find real-world data about the runoff coefficient or the amount of runoff you can expect after a rain event. It depends on a lot of different things, how many rain events you had in the past, how dry is the ground, etc. So what is often done is just using the runoff coefficient. It's basically in percentage. So we assume, for instance, in flat agricultural land, you would get from 10 to 50% of the water that is added as rainfall is runoff afterwards. You can then use this formula to calculate basically how much millimeters this refers to your pond, and you obviously have to know how big the watershed is from your pond. If you don't, and also if you don't have your pond constructed in a way to be, as I said before, to be able to collect this runoff water, there will be no runoff that you can add to your water budget. Exactly. So the next thing is evaporation. You all know that, obviously. I guess it can be a very strong influence on the water level in the pond. You can see it here from Bangkok in Thailand. You have data that has been measured using such an evaporation pan. So it's just basically just a standardized pot or bucket basically that has a net on top, so animals can't drink out of it, and basically either monitor the water level itself or you weigh the water and you get the reduction of water level, this evaporation. And we can see it's quite a significant amount of water is removed through evaporation. It's not directly translatable, these values, to pond aquaculture, because in a bucket of this size, you would expect to have a little bit higher evaporation values. So in literature, you can find this times 0.7. So if you have this data, you multiply it by 0.7 and you get a rough estimate for evaporation values. This data is also difficult to find in a lot of cases. But if you use evaporation data from a region where the climatic conditions are similar to your region, then you should be fine for a rough estimate. Yeah. You can also find the total annual evaporation and kind of try to extrapolate it to the months, but I mean, it will be less precise, obviously. Then seepage, water that goes through the earth and goes into your pond or outside of your pond. It can either be an output or an input. And this is largely depending on how the pond is built. If you see here, we have a Levy pond. It's called a pond that's been constructed using a dam. So if you imagine excavating a pond, as Ben also explained before, it requires quite some digging and excavation, and it's costly. So what is often done is just, for instance, in a sloped area, you just add a dam, and then you have basically a pond behind it. The negative side, or one of the challenges, is that you have negative seepage in the most cases, so there is no groundwater coming into your pond. That's the benefit of having an excavated pond. With earthen walls, their seepage can be significantly, or can be a significant input into your pond, also in dry seasons, when there is still groundwater available. So you can see this around 3 to 6 millimeters per day. You can have very low values in very arid climate, or very high values in very humid climate. So it's always difficult to generalize this data. If you have a pond liner, as we've seen before in pictures of Ben, they practically inhibit seepage. So you will not either benefit from this, or in such a case here, you will also yeah, will also not really have a negative effect on your water level, because 3 to 6 millimeters per day is quite a lot if you think about it. If your pond level reduces by that every day. But as I said, it's strongly dependent on water, on weather and groundwater conditions. Then we have the overflow output. This especially is important if you think if your pond is overflowing. So if you have too much water coming in, then if there's a lot of rain in the rainy seasons, for instance, in Cambodia, it can happen often that water overflows and that water is basically lost from your water budget. But we will see this later when we have this conclusion of the water budget. And there's also intentional discharge. We didn't really talk about this yet, but often these ponds are drained after one cycle. It depends on your management strategy. But we've seen that harvesting from these ponds is kind of difficult. It needs a lot of manual labor. People have to climb in the ponds and so on. Are in the water, you don't see it so well. And also in in our experiences, it's difficult to really get all the fish if you don't drain the pond. So if you drain it, you effectively increase or decrease the water level, so it's much easier to harvest the fish. And it's also easier to remove sludge afterwards once the fish are removed and so on. You don't have mixed cycles in the end. So if you leave a fish like a tilapia and it makes baby tilapias, then you have mixed cycles in the next time you start. And this really is difficult then to calculate feed conversion ratios and so on. So I try to make a scenario for this water budget. So we just assumed we have an excavated pond of 150 square meters. This happens to be the same size as the small pond units in Cambodia that we had. And they are filled to a depth of approximately 1.5 meters from the start. So at the 1st of January, we have this water depth, and then we assume that, then we can calculate the pond water level every month. We have a low runoff coefficient. We have a watershed of 500 square meters, so it's roughly a little bit more than 3 times the size of the pond is used for collection of water. This, as I said before, it implies that this water is actually collected. So in the small pond units in Cambodia, this was not the case. And there was no runoff in those ponds. And seepage was approximated to be 1 millimeter per day. And we can see we have this rainfall data. We get in Cambodia, we have January, February, March, and December are roughly the dry season, and the rest of the year, or especially from May to October, you have a very pronounced rainy season with a lot of rainfall. So it's a good condition to have pond aquaculture. But in turn, you get quite some evaporation as well because the weather is very hot. Here I've used data from Bangkok in Thailand because it was practically impossible to find reliable data from Cambodia. But I just assumed in this model that the data is well enough or good enough for our cause. You might have to do the same for you if you want to do this. We assumed a little bit of runoff. This is calculated with the formula I showed before. We have a constant seepage. This is, by the way, always here positive. So even in the arid season or in the dry season, we assume that we still have an input through seepage. If this is true, I'm not 100% sure. I guess you could also add a minus here. So changes in the dry seasons, because in the dry season also the groundwater level decreases. And you can effectively calculate the change in water level. So we see we have a dry season, we have a strong increase in the rainy season. And that means if we start at 1.5 meters, we first decrease a little bit in water level and we increase strongly after this. up until November when we decrease again. But we see that we have a net surplus of 2,000 millimeters a year. So it's a lot, too much basically. But this means also that you can use this surplus for other causes. I will show this in a second. And what we also didn't consider in this model now is the overflow of the pond. So effectively the pond water level, it would stop somewhere because the pond is not 4 meters deep, right? We don't have a 4 meter deep hole that we only fill 1.5 meters. So the pond is maybe 2 meters deep. So it will stop here somewhere. And the rest of this water is effectively lost as runoff. No, as overflow, sorry. And yeah, you have to consider this when making such a water budget. But it shows us, in this case, that we have more than enough water to produce fish without a significant water exchange. And this is an example, another example from Cambodia, where we did some assumptions in absolute values. So you can see a bit how much water is actually lost. The rainfall comes down. There's a lot of rainfall in Cambodia. A lot of it is lost as infiltration. You can have some runoff. And in the end, you have a surplus that you can use for irrigation. And this is often very important if you have, especially in these small pond units that people have at home, then they have agriculture next to the ponds, and it allows them to either grow crops that would need more water than they have, or to make, for instance, a second cycle of crops. For instance, typically in Cambodia, you have rice production. You can do this once a year, and after that, you don't have enough water anymore because it's dry season. So rice needs a lot of water. So you cannot harvest or cannot do another cycle. So if you have this pond, you can irrigate the rice field and you can produce rice twice a year. So this gives you an advantage, or this gives you additional income. Yeah, exactly. So let's go over to dissolved oxygen. All good. All good. You know by now, I guess, that fish need oxygen in a dissolved form. This oxygen is, however, very poorly soluble in water. We have a maximal saturation or concentration of 14.6 milligrams per liter at a little bit less than atmospheric pressure. So this is basically what you can reach. And you can do more if you add pressure to the equation, but usually this is in a pond, this is impossible. And what is also playing against fish farming basically is that the solubility decreases with increasing temperatures of the water. So the hotter it gets, the less oxygen you have. And it's also in these supersaturated regions because all the algae, they grow on top of the pond, or because they have a lot of solar radiation, they grow there, they can produce a lot of O2, and you get a supersaturated layer. And this can also get to be a problem, as I've said before, with this gas bubble disease. So it's not only good to have high concentrations of oxygen, you have to stop somewhere. Then you can add oxygen if you don't have enough. Usually this is the case if you want to intensify your production. And this is usually done using paddle wheels in such pond aquacultures. We see we have different processes that either produce oxygen within the pond or they decrease the oxygen concentration. They need oxygen. So obviously the fish need oxygen, as I've said, but it's also the sediment that respirates oxygen. So this is, for instance, the case if you have a lot of dead algae, or if you have algae in general, they will die at one time. They will settle on the ground. They will form a sediment, and this organic substance will be respirated by bacteria using the oxygen in the water. You also have a degassing, especially if you aerate the water during the day. This can actually be a negative influence for your oxygen budget, because if you increase the surface area of the water in comparison to the air, you also increase the degassing potential of the dissolved oxygen in the water. So aerating during the day, especially from 12 o'clock maybe to 3 o'clock in the afternoon, can be reducing your dissolved oxygen. We see that here on the right side, we need a certain concentration for fish to be able to survive. There is a desirable range, and obviously everything below 1 milligram per liter is lethal. If exposure is prolonged, I mean, this exposure is not very long. It's in probably half an hour max, if not less. Depends on the fish. Here it's data from warm water fish. They are typically a little bit more tolerable to low dissolved oxygen concentrations, but generally you put a lot of stress onto your fish if the dissolved oxygen concentration is low, so you don't want to have this, because fish will get unhealthy with time. Or sick, we call it, I guess. So artificial aeration, we've talked about it. You have these paddle wheels. This one is not in operation. This one is in operation. So all you do is you take oxygen or air, oxygen from the air, and you add it into the pond. They usually are operated using gasoline, and gasoline is expensive, and this means this can significantly increase your operational costs. Here in Cambodia, they were operated by electricity, which is not very typical. But in this case, it was chosen because I think the infrastructure for electricity was there. And always having a gasoline motor running was also not a very good choice, I guess. You can also see the change in water level, by the way. It's quite significant. In this picture, the water level is up here, and it's probably 2 meters down. So these ponds are very deep. These are the small pond units again. Ben already explained we had different sorts of aeration systems. So we had aeration systems that used electricity, that it was generated using these solar panels, and they basically, all this technology did was to destroy this oxygen layer, this supersaturated oxygen layer, with the hypothesis that this would increase the total amount of oxygen that you can get in the pond. And we had some very good values. Tested this a lot of different times and with a lot of different setups. So this seems to work, at least in the small pond units. So time is already going fast, so I don't want to talk too much. Let's get into pH. You heard it already. It's affected by the amount of feed you add. Fish produce CO2 through their metabolism if they metabolize the feed. So pH will drop, but pH will rise again if the plants and algae in the pond do photosynthesis, because they need CO2 in this reaction. And CO2 is very important for the buffer capacity of the pond. So it increases if you remove CO2, it typically increases the pH. You can see early morning, you can have a pH of 6.5. Late afternoon at 3 o'clock, you have a pH of 9. So it's very significant changes. And there's one thing, fish, they can either tolerate this or not. If they can't tolerate it, you have a problem. But they also need to tolerate the total ammonium nitrogen concentrations, because As you also know, probably, this is very dependent on the pH, how the ammonia is present in the water. So you have either NH3 ammonium, NH4, and actually just the NH3 is poisonous, or I mean the NH4 is also poisonous, but the NH3 is way more poisonous to the fish. And you can check such a table like that. You have the pH on the left side, you have the temperature. And the higher the pH goes, the more percentage, or the more of this total ammonial nitrogen is present as NH3. So if you have this pH of 9, you get up to 50% of your concentration is then present as toxic NH3. You can see short-term LC50 values, so lethal concentrations where 50% of the population die for NH3 are somewhere in the range of 0.1 to 1 milligrams per liter. Depends a lot on the species. Also cold water fish usually are much less tolerable. Tilapia, carp, catfish, they are very tolerable, or they can still live with high concentrations. The question is if they feel good. So we see the maximum of the day we have the worst conditions for the fish. So we have a scenario again. It's just for you to think about what this means in terms of operation of such a pond. You have a tank concentration of 2 milligrams per liter. And we think about, will this concentration be problematic for our fish? We measure in the early morning and the late afternoon. And we see we have a pH of 7, water temperature 28 degrees. We have a pH of 9.2. It's obviously an extreme example, but we can check this table and you will see we have roughly 0.7% in the morning that is of this 10 that is present as NH3, and then this will rise up to 50% in the afternoon. And if we calculate what this means, it means 0.002 milligrams. That's great. The fish are happy. I think this is less good for the fish. It still looks happy, but I guess it's not. Yeah. So that's the end of the presentation. Sala told me that I have to prepare a task as well. And I thought it would be interesting for you to check out, to make a rough water budget for your location, because now I showed you Cambodia, which is a great example to show if you want to see that you have enough water. But I'm sure there are cases where you don't have enough water. And I would be very interested to see this data on the one hand, and I think it's a good example to get to know this a little. If you cannot find data, just make an assumption or use the data that is listed on page 32 of this presentation. Thank you very much for your attention. I hope you found this presentation, this webinar interesting, and maybe we see each other once in real life.
Mute.
Mm-hmm.
Thank you very much to both of you. Does somebody still have some open questions, or Ben and Luca answered everything you had?
Yeah, I had one small comment though before the questions start about trees and plants near your ponds. You need to be quite careful where you put your ponds, as trees, although it looks very nice, the shade can reduce the productivity of your ponds. And also the leaves falling in your ponds can negatively affect the quality of your water. And it's a good place for birds to live, which can also be bad for your fish if it's something like a kingfisher or cormorant and stuff like that. So rather steer clear from trees being too close to your pond.
Thank you, Ben. Georg?
Are any experiences known to you regarding plant protection agents runoff into pond aquaculture? Because in my country, in Germany, 70% of the lakes are contaminated with plant protection agents, a whole variety of them. So I want to know if there's any knowledge about that to you and maybe that influencing the aquaculture in the ponds.
Do you have knowledge about this, Ben? Because
With pesticides or herbicides, or is that what he means?
I guess both.
Yeah.
Yeah, so generally they're not that dangerous for the fish specifically, depending what it is, of course. What can happen is it can affect the algae in your pond, and that can then make your pond quite unstable. I haven't experienced it personally, but so I can't speak exactly on it. But I think it's more dangerous to the algae in the pond, but then that being dangerous for your fish.
Thank you very much. So with this, we then conclude today's webinar. Thanks again to both of you. And then see you in 14 days together with Carlos and Michael. So Carlos will join us as well. And we will discuss the improving nutrient use efficiencies in aquaponic systems. So with this, thank you. And you hear from me with the normal email you get after each webinar. Bye-bye.
Hi, everybody.